page 13. My polyatomic ion chart and periodic table are close by. Let's talk about the first one, HCl. I want to name this as an acid. Well, first of all, I notice that it's binary. And binary tells me that originally we would have named this hydrogen chloride. I'm going to write much larger just so I can fit it into the note pack. You certainly can fit all of this in margin notes, but I want to write large enough so you can see. So HCl. I'm reminding us that it's a binary acid. I would have named this hydrogen chloride. I would have named it, but now let's name it correctly as an acid. If the original ending were IDE, we go hydro, root word, ic. This correctly is called hydrochloric acid. HCl, hydrochloric acid. Number 2, HClO3. I know it's an acid because it starts with an H. ClO3 is the polyatomic ion. Let's find its name. We know H is a +1. ClO3 must be a -1. So I'm going to look through the first column. ClO3, -1, is called chlorate. ClO3, -1, chlorate. We would have named this, prior to this new lesson, we would have named this hydrogen chlorate. 8. But now say it as an acid. The acid rule, if it ends with 8, turn it to ic. This simply becomes chloric acid. Notice how I am not saying hydro. It's simply chloric acid. Notice the difference here. When I hear hydro in the name, I know it's binary. If I am not hearing hydro in the name, I know it's ternary. The absence of saying hydro lets me know a polyatomic ion is involved in the formula. Hydrochloric, HCl. Then simply chloric, HClO3. There's one more in this family, HClO2. Acids start with H. How we name acids all goes by the negative ion. ClO2 is a polyatomic ion who is called chlorite. ClO2 -1, chlorite. We would have named this hydrogen chlorite. Now let's say it as an acid. Acids always start with H, but when ite is the original last name, it simply gets changed to OUS, us. Hydrogen chlorite, named as an acid, is called Cloris Acid. Cloris Acid, HClO2. Let's continue the trend with HClO. Number 4. HClO starts with an H, so I know it's an acid. I know it's a ternary acid, so it must contain a polyatomic ion. Let's find the polyatomic ion whose formula is ClO. And here it is. ClO -1 is called hypochlorite. Here the ITE ending, hypochlorite. So we would have named this hydrogen chlorite. But now let's name it as an acid. Oops, I'm sorry. I forgot my... Let me correct that, please. Sorry. This is called hypochlorite. Hydrogen hypochlorite. That's all one word. Hypochlorite. Please repair that with me. Sorry. Now, hydrogen, H, hypochlorite, ClO. Let's name that as an acid. We do not say hydrogen in this. We simply turn the ite to an us, and this is what it sounds like. Hypochlorous acid. Hypochlorous acid, HClO. That's in bleach, Hclo4 Acid. Let's take a peek at number 5. Number 5 on our paper says Hclo4, Hclo4. This again is a ternary acid. We've had ternaries for many in a row. Cloris acid is ternary. It contains a polyatomic ion. HClO was ternary because it had a polyatomic ion. And this also is considered a ternary acid because there's 3 elements in it. One must be a polyatomic ion. So we'll need to find ClO4. It'll be a -1 because it's being balanced by a +1. ClO4 with its -1 charge is called perchlorate. Perchlorate, all one word. So we would have named this as hydrogen perchlorate. 8 turns to ic, and we do not say hydrogen for these ternary acids. We simply turn 8 to ic, and we come up with perchloric acid. Perchloric acid, HClO4. Let's go back and find our next example. Number 6, H2S. Number 7, H2SO3. And number 8, H2SO4. This looks like a family of acids. Number 6, H2S. Number 6, do you recognize that as a binary compound? It is binary. It only is made of 2 different elements. I know that binary compounds originally ended with "ide." We would have named this hydrogen sulfide. Now it's worth mentioning, why do we have a subscript all of a sudden? It's just all about balancing charge. I know H is a +1, sulfide is a -2. So when I crisscrossed a +1 with a -2, you can see why now the hydrogen has a 2 after it for its formula. Does not play a role in naming it, it's just there to balance charges. Now, to name H2S as an acid, it's binary. The original ending was "ide," so we hear hydro, root word, ic. Name this as an acid, hydrosulfuric, put that syllable in there, hydrosulfuric acid. Say it in your head with me, hydrosulfuric acid, H2S. Binary compounds, we do hear the hydro prefix. Notice in number 7, H2SO3. I bet you recognize right with me that this is a ternary acid. Ternary. That means one of these is a polyatomic ion. Let's find SO3. It's called sulfite. Sulfite, SO3 -2. Do you see why now we have 2 H's in our formula? We're just balancing the charge. We would have named this hydrogen sulfite. A ternary acid now. Ite turns to us, and we simply write out sulfurous acid. Notice how that sounds correct. Sulfurous acid. Ternary compounds, originally ending with ite. Ite turns to us, and sulfite turns to sulfurous acid. Let's try number 8. H2SO4. This also is a ternary acid, making me know that it has a polyatomic ion involved. Ternary compounds are built of polyatomic ions. SO4 -2, we see that as called sulfate. Sulfate. Thinking about the -2 allows me to see why I have a 2 after the hydrogen. It's just there to balance charges. H2SO4 would have been named hydrogen sulfate. Now let's name it as an acid. hydrogen sulfate. 8 turns to ic, and we simply write sulfuric acid. That's called battery acid, sulfuric acid. Hydrosulfuric, binary. Sulfurous, sulfuric are ternary acids with sulfur as its base element. And one more in this series, it's number 9. I see H, C2, H3O2. H, C2, H3O2. This hydrogen carries a +1 charge. It is not combined with the H's in our polyatomic ion. C2H3O2 is a group of atoms acting as a unit carrying a charge. We never changed their subscripts. It's called acetate. Acetate. We would have named this compound hydrogen acetate. But now let's name it as an acid. Acids start with H. Acids are hydrogen ion releasers. 8 turns to ic, and we get something called acetic acid, commonly called vinegar in everyday life. Acetic acid. Hydrogen acetate is a ternary acid named acetic acid. Good work practicing naming. Let's practice writing out formulas. Go in the opposite direction, turning out words into formulas. Working backwards with my handy-dandy chart here, naming acids. Alrighty, so here's what I noticed. Number 1, nitric acid. We have to figure out the original ending on the polyatomic ion. Now here's something to consider. I do not hear hydro. So right away, I know it's a ternary acid. No hydro out front. And I notice the ic. I notice the ic as the last name. If it ends with ic and I'm not hearing hydro, no hydro, just straight ic, the original ending was 8. I need to find nitrate. If the original ending on our polyatomic ion is 8, what we're finding on the polyatomic ion chart is called nitrate. And nitrate is right here in the middle of our first column. NO3, -1, nitrate. So I went to work and found the negative, NO3 -1. What's the element that always starts an acid's formula? You got it. It's hydrogen. HNO3, nitric acid. Our second example says hydronitric acid. Hydroic acid. Work backwards. Hydroic acid. Notice here that it must be binary. Hydro is the first thing I hear, and therefore the original ending must have been "ide." Hydro, root word ic, comes from an original ending "ide." So that means if the original ending were IDE, we're trying to write a formula for the negative ion nitride. Nitride, see these IDE endings? They're coming from the front side of our periodic table. Nitride, N-3. So the beginning here, we've got set with the negative. Acids always start with hydrogen. If hydrogens are +1s, and we know that from where it lives, H's are always +1s. N from nitride is a -3. We simply crisscross and we get a binary acid, hydronitric acid, H3N. Hydro root word ic tells me it was binary. Let's try the third one. The third one is simply nitrous acid. Nitrous acid. Hear the name. Part of learning a language is saying the name. Nitrous. I notice the ending is O-U-S. If the acid ends with us, O-U-S, that tells me the original ending must have been I-T-E. If the original ending is I-T-E, we need to find a polyatomic ion called nitrite. Nitrite, from our polyatomic chart, is NO2 and it carries a -1 charge. There it is, nitrite, NO2, -1. A group of atoms acting as a unit carrying a charge. We know that acids always start with hydrogen ions. So a +1 electrically bounces a -1, and there's our formula for nitrous acid, HNO2. Let's keep working. Number 4, hydrocyanic acid. Hydrocyanic acid. What do you hear? Hydro, root word ic. Hydro, root word ic, tells me it must have been ide. The original ending was IDE. So the name of the original ion was cyanide. Cyanide. Now most of the time IDEs are indeed binary acids. But when I start finding the element called cyanide, it doesn't exist over here. That's one of those rule breakers on the polyatomic. Remember hearing cyanide? It's a polyatomic ion that ends in IDE. Its formula is Cn-1. Ending in ide makes it follow this rule, hydro root word ic. So the original ending is indeed ide. It's just a polyatomic that's doing it. Cn-1. Start it with an H because it's an acid. +1 balances a -1, and we get HCN, hydrocyanic acid. How about number 5? This one is called phosphoric acid. Let's go to work deducing what negative ion that was from. I notice the ending ic, but I don't see hydro. If the ending was ic, the original last name must have been ATE. No hydro, just ic. No hydro ic comes from 8. So the original polyatomic here must have been phosphate. Let's find phosphate. Ic came from 8, and phosphate is PO4 carrying a -3 charge. A group of atoms acting as a unit carrying a -3. If hydrogen is always the first name of an acid, we'll have to crisscross the charges to balance it electrically, bringing a 3 down, H3PO4, phosphoric acid. How about number 6? Hydrobromic acid. Hydrobromic acid. I'm seeing here hydrobromic. Hydro root word ic. I just need more paper. Hang on. Number 6. So notice here, hydrobromic. I've already underlined the important clues to figure this out. Hydro root word ic. What was the original ending? Well, it must have been an IDE. Hydro root word ic. Hydro root word ic must have ended in ide. So we need to find bromide. IDE, bromide. And that comes from right here, bromide, Br -1. If bromide, Br -1, H is a +1, hydrobromic acid, HBr, a binary acid, hydrobromic HBr. Number 7, acetic acid. It's commonly called vinegar. Acetic acid. I just see the ic, no hydro in front. So what was the original ending? Well, the original ending of ic must have been 8. Ic comes from 8. We need to find the polyatomic ion called acetate. Acetate. C2H3O2 -1. Acetate. C2H3O2, and it carries a -1 charge. So when we place our hydrogen out front, hydrogen acetate becomes acetic acid. Do not combine the H's. We wouldn't recognize it as an acid. It has to start with the H in order to recognize it as the acid formula. H, C2H3O2, acetic acid. Number 8, I noticed, and you probably will do the same as I did, it's the same as number 1. We will not do it twice. Nitric acid was already written as HNO3. You've now completed your note pack, and what I want you to do is to shut down the Moodle site and come forward to the front table and grab your homework paper. Come see me if you need your homework.